today I wanted to go over how to find difference quotients. I can never really remember this phrase. I think in the past I've said quotient function or something, but it's because when you're first introduced to this idea, typically, it doesn't really make sense. It doesn't really make sense why. And in fact, when I learned this, I didn't even learn this as a separate unit or in a separate class. But now, this is often brought up in pre-calculus, and maybe even in like honors algebra or something when you're learning about functions. So you're finding the difference quotient for a specific function, okay? And this is in pre-calculus because this difference quotient of a function, so when you're first introduced to it, you just need to find what the difference quotient is of a function. So you need to know this formula, f of x plus h minus f of x over h. And typically, I don't think there's any explanation as to why and what this means, but this is such an important piece in calculus because this is a big part of the definition of the derivative. So just to start with a little bit of intuition, we don't need to get too much into it because I want to do a specific problems and find the difference quotients. But the general idea is that from the slope of a line, we know that it's rise over run, right? This is something we've learned in algebra. Rise over run. So in a way, this is rise over run. Because if we have f of x equal, let's just do an example, 3x squared, okay? This tells me if I give an input of x, my function tells me what to do. It squares that input and then multiplies by 3, and I have an output that corresponds to my input. So here it's my y value, my output at whatever corresponds to x plus h, at an x coordinate of x plus h. And then here it's my y coordinate or value that is associated with my x, like at a specific x. So this is actually a change in y, and then this h, it doesn't look like a difference of anything, but actually this is like doing x plus h minus x, like that, and then this just happens to work out to be just h. But this is actually a change in x values, which correspond to these. So in sort of like a hidden way, this is actually a slope of some line, and we'll figure out what that line is in calculus. But just to give you a little bit of a heads up, or a little bit of intuition about what this even is. But for now, let's focus on knowing what to do and how to find this thing for a function. So let's just use 3x squared as an example. Okay, so first of all, f of x plus h, this is the part that trips a lot of people up and it makes no sense. This x plus h is like one unit, okay? So this is not, it's not f of x and then just adding h. Okay, so it's not 3x squared plus h. It's also not f of x plus f of h. Okay, or not always, rather. It might work out to be that way for whatever reason, but not actually always. Okay, instead we need to put x plus h as an input into my function. So this x is not this x, okay? this x tells me what I'm going to do. So I could just do, I'm going to take an input heart, and I'm just going to do 3 times heart squared. This x, it's usually written as x because when we graph on the xy coordinate plane, we usually, for a graph or a picture, points on that graph are written as ordered pairs, and we pair together the input x with the output f of x, so the independent variable and the dependent variable. So that's why we typically write it as f of x equals 3x squared. But really what it means is f of some kind of input is 3 times my input squared. It's like a set of instructions for what to do. Okay, so if you think of it this way, it might help clarify any confusion with this part, because I do see the x here and people get confused with that. This x is like a placeholder x for any x on the coordinate plane. This x plus h is like, I mean, it's kind of like that, but this is like my specific input. So in this case, f of x plus h is 3 times my input squared. So here it would be 3 times x plus h squared, okay, minus, and then f of x is inputting x, so 3x squared all over h. And so now all we need to do is simplify this thing, so we're going to get an expression, and that's what it means to find the difference quotient. We want to simplify and get some kind of expression. So here you can do a few things. You can either factor the 3 and notice that you have a difference of squares, and go ahead with that. For now, I'm going to go ahead and just expand this thing out. So we have 3 times x squared plus 2xh. We can't forget our algebra, can we? I guess we can, but then we should go back and review. So, yes, this x plus h squared is not x squared plus h squared. We have to do the square of a binomial, so x squared plus 2xh plus h squared all over h. And then I'm going to go ahead and expand this out. So just distribute this 3 here like that. So 3x squared plus 6xh plus 3h squared minus 3x squared all over h. And I wanted to do that because some things can cancel, which makes our life easier. So what do I do here? I see a 3x squared minus 3x squared, so those go away. So I'm just left with the 6xh plus 3h squared over h. And at this point, you can either see that you have this h squared and h here, so you can just go ahead and cancel one from each, okay? Or you can factor out an h from the numerator just to cancel out the h in the denominator, right? But we're going to just simplify this. Just remember that if you do cancel h's, you have to cancel from both pieces because you're distributing this h, because there's a plus right there. So you can't just pick one side, there's a plus. So these two cancel, and we're assuming h is not 0, and if h were 0 in the first place, this whole thing would be broken. Or math breaks, right? Because you can't divide by 0 in the first place. So we're just going to continue along as if h is not 0, and we get 6x plus 3h, and that is our difference quotient. So you would expect some expression with x and h, not always, but something like this. You want it to be simplified. So that's it. This would be our difference quotient for 3x squared. Now, in Calc, when we're doing the derivative, we're actually going to go ahead and find this difference quotient, and then we're going to take the limit as h approaches 0. So if you've learned limits, or you're in pre-calculus and you're interested, this is what the next step is, and that will make this h go away. But that's neither here nor there. So it's just very exciting. So anyways, let's do another example just to get the hang of this. Let's do the difference quotient, DQ, the difference quotient of, or 4, whichever f of x equals 2x plus 7. 4. 2x plus 7. So again, we have our f of x plus h minus f of x all over h. So we just kind of need to memorize this setup, okay? Or just get enough practice and just know it. Okay, so for 2x plus 7, remember that this is just our instructions. So f of something is 2 times that plus 7. So in this case, f of x plus h is 2 times that, which is x plus 8, plus 7, and then minus parentheses f of x is 2x plus 7 all over h. So now I'll just go ahead and expand this out. Expand it out. This minus can be distributed. So 2x plus 2h plus 7 minus 2x minus 7 all over h. And I'm just expanding so that I can cancel things out, if I can, if possible. So plus 7 minus 7, 2x minus 2x. I like it. I get 2h over h, and then h is not 0, so cancel, 2. 2 is my difference quotient for 2x plus 7. It's just a constant. There's no x in it, there's no h in it. And to just tie it all together, remember we said this is something to do with like the slope of a line, right? Without going into too much detail, we know that 2x plus 7, y equals 2x plus 7 is a line, is a straight line, because it has the form y equals mx plus b, where m is our slope, and that slope is 2. The slope of this line is 2, and this is the slope of a line, and we got 2. Curious. So that may or may not be related, and it is, but we'll figure out why later. So let's just do one more example of finding difference quotient. If you are working on specific problems for this and you're stuck, let me know, but hopefully seeing just a few examples written out, hopefully it will help you figure out what to do here. Okay, so one more. Let's do a slightly messier one, but still not so bad. So let's do the difference quotient dq for f of x equals 5 over x squared. Okay. So again, f of x plus h minus f of x all over h. Okay. Same formula. Now we can just do x plus h. Remember, x plus h is one thing. So this is really telling me I'm going to take my input, whatever that is, and do 5 over that input squared. So if my input is x plus h, I get 5 over x plus h squared minus then my input of x, so minus 5 over x squared all over h. So now it becomes this thing. We need to simplify this thing somehow. Now it's a bunch of algebra. So here we have like a fraction thing divided by something else. So we need to find the common denominator of this top part. That's the only way we can do a fraction minus a fraction. So our common denominator, suppose, is x squared times x plus h squared. So for this part, to get this into that, I have to multiply by x squared, then minus 5 times, and then to get this into this, I have to multiply by x plus h squared on the top and the bottom. So I have x plus h squared over h. Okay, messy, but that's okay. We can just keep going. So I'm just gonna expand things out. And also, since we have some kind of fraction divided by something else, I'm going to just go ahead and bring this h over here and do I'll just go ahead and do multiplied by 1 over h, because remember, when we're dividing by something, we're multiplying by its reciprocal. And I'm just going to go ahead and do that because now we have one layer. It's not something divided by something divided by something. We just have one layer. So now I'm just going to expand everything out. So the denominator will be, I'll just bring this h to the front, hx squared times x plus h squared. The top is going to be 5x squared minus 5 times, and here we go again, binomial squared, x squared plus 2xh plus h squared. And I'm only really going to expand this top part because I just want to have all the possibilities, like all the ways I can actually cancel things out. So when I have something minus something, that would be great for canceling out. But the bottom isn't going to do anything if I multiply this all out, because I'm going to have a bunch of like pluses, which doesn't help me. I like to keep this part factored. So now just go ahead and distribute this minus 5. Okay, so I get 5x squared minus 5x squared. Ooh, I like it. I like it. Minus 10xh minus 5h squared all over hx squared times x plus h squared. Sorry about background noise. Cars driving by. Okay, so 5x squared minus 5x squared. Juicy goes away. And now I have, let's see here, I have negative 10xh minus 5h squared over hx squared times x plus h squared. And I'll notice that I have an h here multiplied by everything, an h here and h here. So either, again, just cancel it if you can see that, or factor out the h if you prefer first. Okay, and then cancel this. Okay, so now we have negative 10x minus 5h over x squared times x plus h squared. That's it. I can't seem to simplify this anymore, so we'll just leave it at this, as this. This is our difference quotient for 5 over x squared. And like I mentioned, when we actually find the derivative, we take the limit as h approaches 0, which we haven't actually talked about how to find limits specifically yet. But this goes away, stuff goes away, and it's nice and pretty. So that's good. This might look complicated now, but as we find limits, things get simpler. So hopefully this helps. The key for this is to first understand what f of x plus h really is about, and then just writing this out and being careful with our algebra, even though this looks like a mess. But if you're really careful, write things neatly, you'll get to where you need to go. And so we did one example where it's 6x plus 3h. We did one example where the answer is 2. And we did one where it was a little bit more complicated, but we got minus 10x minus 5h all over x squared times x plus h squared. Okay, I hope that this was helpful. And again, if you have any specific problems or if you're doing this in school, let me know. I'm curious, and let me know how you're doing with it. I'll see you around. Bye bye. Bye bye. Bye bye. Bye bye.